Avacon is a regional distribution grid operator with a strong municipal character that manages the supply area from the North Sea coast to southern Hesse and includes large parts of Lower Saxony and Saxony-Anhalt. Avacon is already facing the challenges posed by the increasing share of decentralized renewable generators in all voltage levels of the electric distribution grid. Even communities in rural low voltage levels display high feed-in as a result of increasing numbers of rooftop photovoltaic systems and high energy demand from electric chargers and heat pumps. To meet these challenges, Avacon developed a local energy management system that implements local balancing that synchronizes consumption and renewable generation within communities in the low-voltage grids by steering storages and flexible loads provided by resident households. Therefore, Avacon participated in the 4-year research and innovation project Platone. Platone stands for Platform for Operation of Distribution Networks and is funded by the European Commission's Research and Innovation Programme Horizon 2020. The key objectives of the demonstrator are, first, to demonstrate a local balancing mechanism for low-voltage networks, second, to develop allocation strategies, third, to demonstrate the informational and temporary uncoupling of low and medium voltage networks, and fourth, to maintain a safe operation of the distribution network by utilizing the flexibility of distributed energy resources. The energy management system, named Avacon Local Flex Controller (ALFC), implements different use cases through services of the distribution system operator's technical platform. The open-source approach allows to profit from the technical know-how and expertise of other partner industries and branches participating in the Platone project when solving complex solutions for the energy transition. Furthermore, the Platone approach removes technological barriers to implementation. The approach of modularization of software solutions simplifies the development of prototype solutions and testing in the field. In the German demonstrator, 4 use cases have been implemented that can be triggered by the energy management system. Services relevant to the use cases that are enabled by the distribution system operator technical platform, named DSO Technical Platform, are standard load profile-based forecasting and microgrid flexibility management. The DSO Technical Platform offers a variety of additional services, such as data storage and visualization services, to improve observation of the grid status. These services can be accessed by well-defined interfaces, in this case REST API, and individually used by transmitting JSON data with specific information. In the following, the interaction of the ALFC with the DSO technical platform in the Platone framework will be described in the example of use case 1 from use case setting until visualization of measured results. Use case 1 aims at reducing the peak load at the grid connection point between the low voltage and medium voltage feeder by using the available storage capacity efficiently with an optimization that puts respect to the limited storage capacity. This use case applies standard load profile-based forecasting and microgrid flexibility management services of the DSO technical platform. A use case is triggered along a graphical user interface developed specifically for the need of the demonstrator. The graphical user interface is divided into multiple sections. The upper left section contains general information and a node field. The upper right section displays the status of the flexibility in the field. The section in the middle contains a selection field for use cases, different options for the approach of local balancing, as well as fields to select the start and end time for the use case. The lower section shows different fields to parameterize additional use case data that is required depending on the selected use case. As an example, we will select the use case 1.2. A schedule-based balancing with optimization is set by selecting option 22, Optimized Schedule Implicit. The ALFC determines a set point schedule to control storages. Now the use case start and end time can be set. By pressing the Submit button, a request is submitted via the request file. The system continuously checks if new, active or blocked use cases are submitted. Real-time data from sensors in the smart secondary substation and batteries in the field, such as the state of energy, are retrieved. The ALFC contains several modules implementing different features and functions that operate and monitor in 15 minutes timing. All components within the ALFC communicate via a REST interface. Retrieved data from assets in the field and computed net power exchange forecast are submitted via the requested file, HTTP-based, to the DSO technical platform to apply the microgrid flexibility management service. The balancing service processes the received information and sets the frame in which the optimization takes place, such as with or without a final state of flexibility in the demonstrator. With these pieces of information, the microgrid flexibility management delivers a schedule in the form of set points to steer the assets in the grid for the use case time period. Each set point is then realized by the ALFC and connected assets. The forecasting service of the DSO technical platform is used once a day by the ALFC. The prediction is used by the ALFC to compute a forecast of the residual power flow at the low voltage and medium voltage transformer of the field test community for up to 2 days ahead. To get such a forecast, the ALFC submits input data as forecasted photovoltaic generation and standard load profile for the community consumption to the forecasting service via an HTTP call. The ALFC receives the photovoltaic forecast via a weather data provider. The effect of the steering is visualized on a use case dashboard specifically designed according to the needs of the demonstrator. The use case dashboard shows 4 panels. The first panel shows a green and a gray curve. The green curve visualizes the actual measured power exchange at the low voltage and medium voltage grid connection point during the running use case. The gray curve visualizes a computed baseline of the power exchange. The line indicates the power flow that would have been measured if no use case would have been applied in the field. The second panel shows the charging and discharging behavior of the flexible asset, which means the community storage unit during the use case period. The panel in the middle left section shows which use case is running. The panel in the middle right section shows the state of energy and state of charge of the storages in the field. The panel in the lower left section shows the residual power flow forecast that was used to generate a set point schedule for battery steering. This example shows the significant impact of controlling flexible assets in the grid to reduce power peaks. It illustrates how the load curve indicated in gray is successfully reduced from about -280 kilowatts to -180 kilowatts due to flexibility control. The resulting load curve is indicated in green. The example shown has demonstrated that the interaction between ALFC and DSO technical platform could successfully implement a use case that contributes to relieving the load on the power distribution network.